We're going to go ahead and take a look at inverse trig functions. Arc sine is identical in meaning to sine inverse of x, or arc cosine is the same as cosine inverse of x. Arc tangent is tangent inverse, or arc cotangent is cotangent inverse. Your inverse cosine and inverse cotangent are defined only in quadrants 1 and 2 between 0 and pi. Your inverse sine and inverse tangent are defined in quadrants 1 and 4 from negative pi over 2 to positive pi over 2. Which for the most part means if you have an answer that's down here in the fourth quadrant, you need to rotate backwards and give me a negative angle. You would not give me 11 pi over 6. You would go from here rotating back to that spot, so that would be negative pi over 6. Or this one here, which is at 7 pi over 4. You would not put down 7 pi over 4 because it goes beyond a half a pi. You would say I start at 0 and I go backwards to negative pi over 4. So anything you get that's in the fourth quadrant is going to be a negative angle. So this is an inverse trig function, so it's representing an angle. It really means the cosine of what angle gives us root 2 over 2. And being an inverse cosine, we have to remember we are limited to quadrants 1 and 2. So where in quadrants 1 and 2 are we equal to cosine being root 2 over 2 positive? And well, that's at pi over 4. It is important that you know exactly which quadrants each one of these trig functions is defined in. That will be important as you move forward here. So let's look at this. Sine inverse of negative 1/2. It's an inverse trig function, so it's representing an angle. But what angle? Well, this means sine of what angle is negative 1/2. And because it's sine inverse, we have to limit ourselves to the first and fourth quadrant. Well, we know sine is negative in the fourth quadrant. Remember, I'd said before, if we're ever in the fourth quadrant for an inverse trig function, you got to start at 0 and rotate down. So this would be negative pi over 6. Here, it's an inverse trig function. Arc cosine or cosine inverse is the same thing. So it's representing an angle. It means the cosine of what angle is negative 1, and we have to be limiting ourselves to quadrants 1 and 2. Where in quadrants 1 and 2 is the cosine equal to negative 1? That is at pi. Here, it's inverse sine, so it's representing an angle. So the sine of one angle gives me out pi over 2. And I have to limit myself to the first and fourth quadrant. So when is sine of what angle gives me pi over 2? Well, remember pi is a little bit more than 3. Divided by 2 would be a little bit more than 1.5. But the sine of anything is always between 1 and negative 1. So it would never get to 1.5. Or if you remember, sine of anything is always between 1 and negative 1 because your sine graph goes from a height of 1 to a depth of negative 1. It would never reach a height of 1.57 or pi over 2. Here, the inside is a normal trig function. We're just doing the tangent of pi over 4. You should know the inside tangent of pi over 4 is just 1. It's still the arctangent of that. So now we have to do the arctangent of what we just figured out. Arctangent is an inverse tangent, which is an angle. Any inverse trig function is representing an angle. This would mean tangent of what angle is 1. And then remember, inverse tangents only in quadrants 1 and 4. So where in quadrants 1 and 4 is tangent equal to 1? And that's at pi over 4. Here, we're going to work from the inside out again. Sine, normal sine, not inverse, sine of 2 pi over 3. So go to 2 pi over 3. The sine is the y value at that point. You should know that that is root 3 over 2. We still then have to bring down our inverse. So we now have an inverse sine of this. Inverse sine is an angle. What it means is the sine of what angle is root 3 over 2. And then remember, you have to be limiting yourself for inverse sine to quadrants 1 and 4. So where in quadrants 1 and 4 is sine equal to root 3 over 2? And that's at pi over 3. So once again over here, you work from the inside out. The inside is an inverse trig function, so it's representing an angle. So we'll eventually be doing tangent of some angle once we figure this out. The inside means cosine of what angle is 0. And you have to be limiting yourself to quadrants 1 and 2. Where in quadrants 1 and 2 is your cosine 0, and that is at the top of the unit circle at pi over 2. So now you just have to do the tangent of that angle. And the tangent at the top of the circle is y over x, or sine over cosine, so it would be 1 over 0, which is undefined. So here we have an inverse trig function. Remember, an inverse trig function is representing an angle. So this underlined blue thing is an angle. Oh, here we have an inverse trig function. So that's an angle, a different angle. So we have a cosine of an angle plus an angle. Oh, cosine of an angle plus an angle, we've dealt with that before. So let's look at what this first part means. We know it's an angle. It really means the sine of some unknown angle is 4 over 5. That's not one you're supposed to have memorized. So we could draw ourselves this on the unit circle, or draw ourselves a triangle for this. Now, remember, inverse sine is only in quadrants 1 and 4. Inverse sine is positive in quadrant 1, so we're going to draw our triangle in quadrant 1. Remember, you come out into quadrant 1, make a right triangle to the x-axis. Your angle alpha is always in the triangle at the origin. Sine is opposite of your angle over your hypotenuse, so it's 4 over 5. Then all you have to do is use your Pythagorean theorem to figure out your missing side. This is also an angle. It means tangent of what angle, we're calling it b, is equal to 3 over 4. Inverse tangent is also defined only in quadrants 1 and 4. And tangent's positive only in quadrant 1, so we draw a triangle in quadrant 1 with the opposite and the adjacent, being 3 and 4. Hypotenuse by the Pythagorean theorem would be 5. We now have the cosine of our blue angle plus our green angle. Cosine of two angles added together, we can go cosine of the first angle, cosine of the second angle, minus sine of the first, sine of the second. So go cosine A, so we go to A, we do our cosine 3 over 5. Cosine B, we go to B, we do our cosine 4 over 5. Bring down our minus sign, then we go sine of A. So go to angle A, do our sine 4 over 5. Sine of B, well, we go to B, we do our sine opposite over hypotenuse. So now we're just multiplying fractions. Multiply the tops, multiply the bottoms, multiply the tops, multiply the bottoms, and we get 0 for this case. So here we have an inverse trig function, which is an angle. So we really have sine of 2 times an angle. Oh, sine of 2 times an angle, we've dealt with that before. Now, when we look at this angle, tangent inverse is an angle. It really means tangent of what angle is 5 over 12. So we should be able to draw that. Remember, inverse tangent's only in quadrants 1 and 4, so we'll draw our triangle in quadrant 1 because tangent's positive in quadrant 1. We draw our triangle, opposite over adjacent, do the Pythagorean theorem to figure out your hypotenuse. So we now have sine of 2 times some unknown angle, but we drew that angle. So sine of 2 times our angle, we have a formula for that, 2 times the sine of our angle times the cosine of our angle. So we'll go 2, go to our angle A, do our sine opposite over hypotenuse, 5 over 13. Then we'll do our cosine. Adjacent over hypotenuse, 12 over 13. Now we're just multiplying three fractions together. 2 over 1 times 5 over 13 times 12 over 13, and we get 120 over 169. Oh, same type of stuff here, except we have an x here instead of a number or a fraction. But it's still an inverse trig function, which is representing an angle. So the whole inside's an angle, and we're just doing the tangent of that angle. And I'm calling that angle B. So when I look at what this inside means, it means cosine of some angle, I'm calling B, is x. Or x over 1, because then it says a fraction and works better for SOHCAHTOA. So I'm going to draw myself a triangle. And let's see, it's adjacent over hypotenuse. So I draw myself a triangle. Adjacent would be x, my hypotenuse would be 1. Then I can do x squared plus question mark squared equals 1 squared and solve it for my missing side. When I do that, I get the square root of 1 minus x squared. Now looking at this, I want the tangent of my unknown angle. So I want the tangent of the angle I just drew. Remember, tangent is opposite. Well, that's the root of 1 minus x squared over adjacent, which is just x.